Okay, so welcome to the final leg of our SQL exam on the movie database. We are on question 11. We did question 10 in the last video. So let's quickly go into it. Question 11 reads, which genre has on average, the lowest movie popularity score? Which genre has on average the lowest movie popularity score? So we know where the genre table is, and we know its relationship to the movie table, which contains the popularity score. And we know we can go to from the genres table to the movie table. We have to go through the genre map table, through the genre ID, and then finally to the movie ID. So we need to join this table. So let's go quickly and then go and look at it. I think the previous videos we have explained some of these things, so we will not repeat the same thing again. Okay, so here we are looking for the genre. I say which genre, so the genre name must appear. So I say I want the genre name, and then we also want the average popularity from the movie table. I want to call it average popularity. Then we are looking for this from the genre table. Now we are joining the genre table with the genre map table on the genre ID, and then we join the movie table also to the genre map ID through the movie ID. Okay, and then we are grouping it by genre name. So we are asking this query to go into the database and then select the unique genres that we have, and then put together their popularity score by the genre, and then take an average of each of the genre. That is what this one does. So it's ordered by the average popularity, and we want it in ascending order because ascending is from the lowest to the highest, and the question asks of which one is the lowest. So if we limit it to 1, what will appear when we query this or execute this query, then we'll be getting what the genre that is with the lowest movie popularity score. So when I run this query, you can see here we have the foreign genre. The genre name is foreign, and we can see its popularity over here. If you want to see whether maybe really this is the lowest, probably you can limit it to, let's say, 5, and then see the figures that you are given, and then compare and see from the ones you have which is the lowest. Okay, so you can see from here that is foreign is 0.68 blah blah blah, documentary is 3.9, which is higher, followed by TV movie, which is 6.389, music and blah blah blah. So obviously this is the lowest. So limiting it to 1 is just to return exactly what you want without getting anything extra. For comparisons, you may want to increase the limit so that you can compare the figures with other ones, and then you are very much aware that that is it. Okay, so we know now the number 11 is done. Let's come to number 12. Say which award category has the highest number of actor nominations. By actor nominations, they mean actors can be male or female, so both. Now hint, Oscars.name contains both actors' names and film names. Okay, so now we are being given a hint that we could find some information in the Oscars table, but then yes, we can find some information in the Oscars table. If you just we write the query, select all from the Oscars table, we'll see how the Oscars table looks like. We can also go to the ERD to also look at the relationship of or how the other columns are arranged within the Oscars table. So we look at award, which is talking about the category. So I say award category. I want award, and I want this as what? Award category. Then I want to count the name. So here we are counting the name as what? Nomination count. Now this we are taking it from the Oscars table, but then if we deal with the Oscars table alone, we might have figures that does not correspond with what we have in the other tables, like the movie table, the cast table, and so on. So in order to ensure that the information that you get from the Oscars table actually corresponds to the movie table and then the cast table, because the movie table contains the title of the various movies, but in the Oscars table the title is renamed as film. So what you see as title within movies table is now called the film in the Oscars table. So you can compare and see that you want to read these results returned to you where the film is equal to what? The title, so that you are looking at the same figures, or you are comparing the right thing. Now we also want to join the cast on movie ID with the movie table. Now the cast also contains the various people that played what role in the movies that we have, and they also correspond to the movie table. Now there are the cast does not only contain the actors and the actresses. Note that the cast does not contain only the actors and the actresses. So we also connect again to the actors table, which now contains specifically the actors, both male and female, in that particular table. So here we only do not want to query or to select the award and then count the award names. If we do that and then we close the query, we may have issues. Now I am looking at what you can call that a little bit of a difficult one or option, because I am looking at the specific answers that have been provided, the options that have been provided. I want to query to find out, to compare these four over here to see which one is the highest. So I am not actually looking into the table to return all the various categories of award and then the various nominations that they had, but I want to dwell on the four options that have been given so that I can quickly get my answer and then I go. So my query is to compare the four options that have been given for us to select our answers from. So whatever the case may be, they will have the values that correspond to these four options. So from here, after we have joined the tables, we are looking at from where the Oscar, the name is equal to what? Actor in the actors table. That is the actor name in the actors table. So it runs through now, and we are saying that another condition should be met That is because I want to compare the options that I'm given. So I want where you have in award, special achievement award, actor in a supporting role, actress in a supporting role, and then the best picture. That is it. So I'm grouping it by the award, and then I want to also order it by the nomination count. By the nomination count. Because the question is to find the highest, I will order it in the descending order so that it starts from the highest to the lowest. Now when you execute this, when you run this query, you will see that it returns these two. The other two does not actually appear. It may be suggesting that within the particular year under review or the space of time that the database is collected, these two other rows probably do not have. So let's look at it. You can see actor in supporting role having the highest, followed by actress in supporting role. So I have my answer. Comparing these two alone tells me that the highest is the actor in a supporting role. Now for the purposes of this video, I created another cell to have another option of the same answer, or which will give you the same answer. The other option is to write the query up to this end, and then you just put where the Oscar's name, the name column in Oscar is equal to what the name column in the actors table, and then you group it by award and order it by the count name, or here let me say I did nomination count, so that is what is supposed to be here. Okay, so I have nomination count here and it works. So in a descending order, it also should give you every award and the way they have been arranged, or the awards that they have received. So you have it here. You can see you have actor in supporting role still having the 165, actress having 142, and so on and so forth. You could see that still the other two does not appear, so probably that they are recording 0 or something. So any of these two queries will give you the answer that you are looking for. Take the easier option and then we move. So I'm moving to question number 13. Question number 13 reads, for all the entries in the Oscars table before 1934, the year is stored differently than in all the subsequent years. For example, the year would be saved as 1932 by 1933 instead of just 1933. The second indicated year, that means that the second indicated year is actually what they may be referring to, but then they have added the previous year to it. Which of the following options would be the appropriate code to update this column to have the format of the year be consistent throughout the entire table? That is the second indicated year only shown. So you want to remove the first indicated year. Okay, that is the first four figures that you have over there. You want to remove it and then leave this one alone. Okay, so please let's look at the options that you have been given. Clearly you update. If you look at the queries that you have here, update OSCAS set year to write. No, this will not give you the answer. This will not give you the answer. So you come to the next one, which is update OSCAS set year is equal to select subtract. That will also not give you the answer that you are looking for. So like you see here, the answer is in option 3, which is update OSCAS set year is equal to subtract, and then you have year and then -4. This will give you the desired results for number 13. So let's move to number 14. Okay, so 14, we are supposed to look at which of these queries work. For the purposes of this video, I inserted a few cells just to make demonstrations. The caution is that we shouldn't insert or create any additional cells, so you work with that, but just for the purposes of this video I did that. Okay, so here we have been given these options to select from. We say DSTV will be having a special week dedicated to the actor Alan Rickman. Which of the following queries would create a new view that shows the titles, release dates, taglines, and overviews of all movies that Alan Rickman has played in? So we are looking at a view table that captures all the movies that Alan Rickman has played in, and you want their titles, you want the release date, and then we want taglines and overview. So which of the queries does perfectly that? So as you can see from here, option 2, which is create view Alan Rickman movies as select title, release date, tagline, and overview as the columns, and then you are querying it from, or you are selecting it from the movies table. Now we are left joining with the cast table on the movie ID to the movies table. Now the reason why we are doing this, you know, when we do the left join, we are supposed to return, it is supposed to return all the information on the left and then returning null in the right spaces. And then we do the same thing for the actors on the cast, where we join the cast through the actors ID, and then we join it with the actors table also on the actors ID. Now we say where actor name is Alan Rickman, and with this we can be able to create that view table. If I execute this, because I've done it already, it will tell you that this view table already exists, so I don't need to do it again. So option 2 gives us the answer that we are looking for. Now let's go to the last one. The last one is which of the statements about database normalization are true. If you have gone through all the models as you are supposed to do, you will realize that the normalization is one of the last models you do before you get to 21. As a matter of fact, I think it is on let me see if I can see it. I'll go back to it. So let's look at the answers. So I have option 2, which is I and I. So like you can see, I put over here the normalization database normalization are actually true for these two situations. So you have the database normalization improves data redundancy, saves on storage space and fulfills the requirement of records to be uniquely identified, and so on and so forth. So basically this is it. The option I and I, this is the option 2, serves the purpose. If you want to look at it, let me quickly show you where you can find this, so you also compare if my suggestions of the answers are actually correct. Just a moment as we have this load. Okay, so let's go here. So you can see normalization here. Normalization is here. You can always go and have a look at everything in there. Okay, so that brings us to the end of our video on how to solve these 15 questions of SQL exam on the movie database. Good luck. I hope everything falls through for you and you get 100%. Thank you.